that later. So the next thing I want to talk about is phases of the moon. The object of this section is to understand why the moon looks different at different times of the month, and why it is seen at different times of the day at different times of the month. So first, the moon takes about 29 days to orbit the Earth. The orbit is in the same sense as the rotation of the Earth and revolution of the Sun, namely it's counterclockwise when viewed from above the Earth's north pole. Its orbit around the Earth is tilted a few degrees from the plane of the Earth's orbit around the Sun. And that's going to be important when we try to understand eclipses. So the moon does not produce light. It reflects light. So the changing appearance of the moon is caused by the changing angles of illumination from the sun. When the illumination is mainly from the back, we see a crescent moon. When it's mainly from the front, we see a gibbous moon. Crescent is less than half lit, gibbous is more than half lit. So at new moon, the moon passes between the sun and the Earth. Because of the tilt of the moon's orbit with respect to the Earth's orbit around the sun, they're usually not perfectly aligned, so eclipses occur only rarely. At true new moon, only the back of the moon is illuminated, so we do not see it. Conventionally, we often refer to the moon as new when the first crescent is visible a few days after a new moon. The first sighting of a crescent moon after the true new moon is of great significance to the Islamic religion. At this time, we can sometimes see the dark part of the moon faintly illuminated by light reflected back off the Earth. So, as we move through the month, the moon waxes, meaning its illuminated fraction increases, through the first quarter, 1 week, to full moon after 2 weeks. It's first crescent and then gibbous. So from full to new again, the moon wanes through gibbous as far as the third or last quarter, and crescent new moon. So as seen from the Earth, we have a new moon. We can't see any of it. It's waxing crescent here. It's first quarter. It's waxing gibbous here. Becomes full, and then it starts to wane and get less light. So it's waning gibbous here. It's third quarter. And waning crescent, and then back to new moon. And what we see and when it rises and sets is going to change. So for example, if I'm standing here right at sunrise, the third quarter moon will be directly overhead. At sunrise, a full moon will be just setting, and a new moon will just be rising. So by looking at this, if we see the sunlight coming through, we can see at different times, for example, at midnight a full moon will be directly overhead, or a first quarter will just be rising, or a third quarter will just be setting. So when can you see the moon? Assuming that you're in an ordinary part of the Earth, not near the poles. So at new moon, the moon passes between the sun and the Earth, but because of the moon's orbit with respect to the Earth, they're usually not perfectly aligned, so eclipses occur only rarely. First quarter is seen in the evening, a full moon is seen all night, last quarter moon is only seen in the morning, and a new moon is essentially invisible. If you ever want to use a telescope to view the moon, first quarter is the best for looking at the moon. Now, the moon keeps the same face always pointing towards the Earth. That's why we can, in principle, recognize the man in the moon. The only people who have seen with their eyes the back of the moon are astronauts that have been in orbit. We're going to discuss reasons for locked rotations later in the course, but essentially the moon's rotational period is the same as its orbital period. The moon rotates once for every time it goes around, so the same side is always pointing towards Earth. So this picture here is going to give you some idea of the scales. So here we have Earth and the Moon. This is not how close they are to each other, but it shows you kind of an idea of how big they are compared to each other. The Earth's diameter is about 8,000 miles, 13,000 kilometers, and the Moon's diameter is about a quarter of that. The Earth-Moon distance is about 400,000 kilometers, or 30 times the Earth's diameter. So eclipses occur when the Earth and Moon are well enough aligned to form shadows on each other. A solar eclipse occurs when the Moon comes in front of the Sun. These are pictures of an annular solar eclipse in October of 2005. It's annular because the positions of the Moon and Sun are such that the Moon is actually a little too close to the Earth, and so it doesn't actually block everything away, and so we see an annual of light around it. Sometimes it's a total eclipse, sometimes it's only an annular eclipse. So the angular diameter of the Moon is almost the same as the Sun, so they have to be almost perfectly lined up to see a total eclipse. A total eclipse only lasts a few minutes, however the effect is spectacular. Solar eclipses can only occur at the new moon. A lunar eclipse occurs when the Earth comes between the Sun and the Moon, and so the Moon looks darker, almost a blood red. A lunar eclipse is visible from half the world, and they can only occur at a full moon. The Moon is still faintly visible during the total lunar eclipse because of scattered sunlight from around the edges of the Earth. The Moon shines then with a faint red light because remember the blue light is scattered out of the Earth's atmosphere. So this figure shows us how we can see why we sometimes have eclipses and sometimes not. Because the Moon's orbital period is tilted at 5 degrees with respect to the Earth's orbital rotation around the Sun. So at this point in time, the Moon is below the Earth, and so the shadow of the Moon during a new moon goes below the Earth. Or the shadow of the Earth goes underneath the Moon, so you don't get a lunar eclipse. And the same thing happens over here. But certain times of the year, February and August mostly, even though it's tilted, the planes line up. And if that's the case, then we'll get a solar eclipse when there's a new moon, or we will get a lunar eclipse during a full moon. Now if you go to some NASA websites or spaceweather.org, you can get some pictures of what different annular or solar eclipses are going to look like. This is the 2010 annular eclipse. And you can see a map here, and it shows you where you're going to be able to see the annular eclipse, where you're going to be able to see some of the sun blocked. In this case, we noticed that it was visible in Africa and in China. Most of it was out in the ocean, the Indian Ocean, so most people didn't get to see this eclipse. The 2012 eclipse, this is a time-lapse picture of the eclipse. It was a total solar eclipse. And as we can see, it was visible briefly in Australia, but most of the eclipse was only visible out in the middle of the ocean. So since the Earth is mostly ocean, a lot of the times we can't see an eclipse on someplace on land. If you ever have a chance to see an eclipse, I highly recommend you go see it. There's lots, though, online, great pictures of the eclipse. This is pictures, this were taken in Iran, and this is the 2010 eclipse. You got this picture of the bird. There's another picture taken by the same photographer as a flock of birds came between the sun during this eclipse. These are pictures of the annular eclipse. Remember, annular means that not all the light or not all the sun is blocked. So for more information about eclipses, visit the website eclipse.gsfc.nasa.gov/eclipsehtml. And that concludes Chapter 2.